Okay, in this question we have a magnet falling through a coil. The magnetic field produced by this magnet is of course not uniform. It's strongest here and weaker as you go further away from the poles. So as the magnet falls through the coil, this coil is going to see a changing magnetic flux linkage. The flux linkage is going to start from a small amount, increase to a maximum, and then starts decreasing again. So if we were to sketch out the variation in the magnetic flux linkage seen by this coil, it's going to start from a very small amount, increase to a maximum, and then falls back to 0 as the magnet falls through. So what we have sketched is the magnetic flux linkage seen by the coil. What we are interested in is the induced EMF in the coil. So what does Faraday's law tell us? The magnitude of the induced EMF is directly proportional to the rate of change of magnetic flux linkage. So we are talking about the gradient of this graph here. So there's an important landmark here. So at this point, the rate of change of magnetic flux linkage is 0. The gradient is 0 here. So there's a 0 at this point. The induced EMF should be 0. And you see the gradient becoming steeper and steeper, probably steeper about here, before the gradient falls towards 0. So somewhere here you should get a maximum induced EMF. And let's just join up the points. And from this point onwards, well, you see the gradient starts from 0, becoming steeper and steeper, and before the gradient falls back to become flat again. So we'll have something like this. Actually, if you really want to reflect this negative sign here, then the graph we had sketched should have been like this. But you know, the sign of the induced EMF really it does depend on the way that you connect your voltmeter here, right? So we don't really bother about the sign here. Just choose the one that correctly shows the gradients becoming steeper and steeper, becoming 0, and then becoming steeper and steeper again. But because that was an increase, this was a decrease, so the induced EMF should be of a different sign from here. Okay, ta-ta!